Okay, folks, in this video, we're going to talk about setting up some exponential functions. These are some really basic ones. Frequently, they say appreciation, depreciation. They might call it exponential growth or decay. This is also annual compound interest. Okay, so the formula is A equals P times parentheses 1 plus or minus R, close parentheses to the T. It is plus if you are gaining interest, if something is appreciating, or if it is exponential growth. It is minus if something is depreciating, which means it's going down in value, or if it is exponential decay, meaning you're going to have less. Okay, frequently we see that with half-lives and other radioactive materials. So, A stands for amortization. That's simply the amount you have at the end of the time period. That's not the exact definition, but that is simple enough for what we're going to be doing. The P stands for principal. That is how much we start with. The R is the interest or growth rate. They will give it to you as a decimal, but you must, they'll give it to you as a percent, but you must convert it to a decimal. Okay, and lastly, T stands for time. Okay, in these problems, we're not going to be changing the time period on you or the time units. So here we go. Here's our first example. A population of fungus grows 13.4% per hour. If the mass of the fungus is 125 grams to the nearest tenth of an hour, how long will it take the mass to reach 1,000 grams? Now, I have the formula already completed there in front of you. We start with 125 grams. Because it is growing, it is plus, and it's 13.4%. So as a decimal, that is 0.134. You could say A in this case, or if you want to say Y, doesn't really matter to me. But in this case, it has the X. Typically, just because that's what Delta Math uses, that's also what our calculator uses. Now, it is totally possible to solve these by hand. However, you would need to use logarithms. We're trying to avoid using logarithms at this time. So here we go. We're going to use the calculator. So I got our calculator set up here. So if you go to the Y equals menu and you type in our 125 parentheses 1 plus 0.134 close parentheses to the X. That's our equation. Then I'm going to go to the table. So I'm going to press second and graph. And I want to see how long it takes me to get to 1,000 grams of this fungus. And if you notice, okay, that occurs sometime between 16 and 17 hours. But that's not good enough. They want to know to the nearest tenth of an hour. So here's what we're going to do. We're going to use the table feature on the calculator. And I'm going to change how it goes. Instead of going by ones, they want to the nearest tenth. So I'm going to have it go by tenths. So I'm going to press second and window. That's the button right next to the Y equals. Okay, I want it to start at 11. Or in this case, let's double check that. Okay, we said it happens between 16 and 17. So I'm actually going to go back and I'm going to make that say 16. Now I want it to go by tenths. So that is 0.1. And press enter. Now when I press second and graph, when it brings up the table, notice that it goes 16, then 16.1, 0.2, 0.3. It's not going by whole numbers. It's going by tenths. So as I scroll down here, I notice that it's sometime between 16.5 hours and 16.6 hours when it reaches 1,000 grams. Well, 995.4 is closer to 1,000 than 1,008.1 is, so I would estimate that this would take about 16.5 hours. Okay? And if we scroll down here, we'll notice that that is exactly what it takes. Now, if I have another problem here where instead of things going up, the number goes down, Okay, that's what I have here in example 2. I purchase a car for $22,500. I find that the vehicle depreciates at 19.2% each year. To the nearest tenth of a year, how long until the vehicle is worth $2,300? I'm going to do the exact same thing in my calculator that I did before, but first I have to write my equation. Okay, I need to know when it's going to be worth $2,300. I know that I start with $22,500 and it depreciates, which means it's going to be 1 minus 0.192. So, 0.192. Okay, so now what I could do is I could use a very similar situation like I did before. I'm going to type that into my calculator, and in doing so, I'm going to find out that these numbers change a pretty fair bit. Now, if you're going to be using the online calculator, you cannot use the numbers at the top of your keyboard. You have to use either the keypad or use the arrow to key in your formula, which is what I'm trying to do right here. And then to the X. Now, I don't want it to go by tenths just yet. That would take me a while. So I'm going to have it start back at 0 and change the table back to going by ones. Okay, so that's going to let me take a look at the table and figure out about how long until I get to that 2,300. And that occurs sometime between year 10 and year 11. Okay, so that tells me that I'm going to make the table start at 10 and go up by 0.1s, because again, I want the nearest tenth of a year. And then I'm going to press second and graph. And I see that it goes from $2,348 to $2,298 sometime between years 10.6 and 10.7. Well, 2298 is really close to 2,300, so I'm going to say this answer is 10.7 years. Okay, and that's exactly what I have here. Hopefully you found this video helpful, and if you need to, you are welcome to go back and review any portion of it. Good luck.